Hi, good morning, everybody. This is Jeff Nagel. Sorry if there is going to be some occasional hammering in the background. Unfortunately, every house in my neighborhood is being flipped right now, and the construction noise is omnipresent at every hour of every day. I did my best to block it out, but fingers crossed that nobody starts jackhammering. All right, so this is a talk about personal rapid transit and the development of system sciences that are not quite cybernetics and the ways that they bleed in between cybernetics in popular understanding, and personal infrastructure, and the attempts to rebuild the city. This is a small chunk of my dissertation. Unfortunately, it's also sort of a project that got frozen in the middle of a research trip when COVID came down on us. So I apologize. Any gaps are obviously my own. In the spring of 1973, Lawrence Fabian, a young environmental engineer and urban planner with the Alden Self-Transit Systems Corporation of Cleveland, a subcontractor on a federal project to build something new and exciting in Morgantown, West Virginia, proposed that the causes and the solutions of the crises facing America's cities, pollution from smog to burning rivers, sprawl that created physical and economic gridlock, segregation, strife of the late 60s urban rebellions, were essentially cybernetic ones. The city, as he argued in Transportation in the Cybernetic City, Planning the Next Generation, was not only best understood as a system of information, but all of its problems were linked in a growing feedback loop. The solution to this was straightforward. The personal rapid transit system, the Alden Star Car, which would use urban cybernetics to send commuters along concrete tracks through the sky without the noise or the smog of cars, thus returning the former advantages of inner cities and solving the urban crisis in one swift fix. If the second industrial revolution, he wrote, represents the mastery of technology of information and controls, then personal rapid transit represents the application of this cybernetic expertise to transportation systems. Sophisticated computer controls managing a large fleet of small vehicles offer individualized service at viable costs. In practice, this meant a series of concrete paths and steel boxes going in a circuit around the college town of Morgantown, West Virginia. But taking advantage of our current format, I can let them explain it to you in their own words.
We have become dependent upon the automobile. But as great a convenience as it is, the automobile has also helped to create some of America's most difficult problems. It uses huge quantities of energy. It is a contributor to environmental pollution. Its bulk clogs and congests our cities. Experts agree that to some of these problems, practical solutions must be found. And people are working on answers. Come, take a ride of the future.
What the PRT was, in essence, is a trolley system that dials into individual stations. As passengers request their destination, cars will queue up and take them there once there's enough passengers. While it was universally described as futuristic and with its computer controls, everywhere in early writings about it, I cut an entire page of just clippings from different West Virginia newspapers that came to cover it. You have to understand that this is not what exactly Elias et al. Were considering their project to be in the first place. Similarly, I think it's very easy to treat this system as just a sort of odd boondoggle, as everything from Aramis to Headlights, the magazine of the electric railway industry, treated it. The PRT actually has its theoretical origins, at least this PRT, in the late 1950s research of Sammy Elias, the engineer who ended up masterminding its construction in West Virginia, specifically in the scheduling of buses and the ways that the city and a city's transit network can be modeled in order to most efficiently allocate the resources of a transit system, thus, again, returning the advantages of downtown to, downtown and removing those advantages from the suburbs. But it's also important to remember that the PRT is less a monorail, some failed technical fix, than it is a dial-a-ride system. The importance for Elias and even for UMTA was that it allowed for individuals to request it to go wherever they wanted, to flow as individual atoms on whatever path they might desire, rather than follow the vicissitudes and schedules of a real bus system. Hence the reliance on the horizontal elevator metaphor, that this is something that you can call to the exact place that you want it, thus replacing a car. And in the same way, it's important that this builds on Elias's earlier work, not as a engineer of technical equipment, but as a scheduler of bus systems, right? This is a way to efficientize the calling of transit and to make the way that a transit system operates more akin to the individual automobile. And of course, it's also just a way to avoid the powers of drivers. There's no possibility for a computer going on transit drive. And contrary to Fabian's claims that this is essentially a cybernetic project, the underpinnings of the PRT model, both in Elias's case and in the case of the larger field, this is actually drawing from a different wellspring of system sciences, right? This is drawing from engineers' network flow theory, by which transit engineers model the city and the flow of people through it as a system of liquids, of fluids. And what PRT is, in essence, is the direct instantiation of that, not in terms of a roadway that you might drive on, something that you sort of see in aerial view, but in a system that will make these flows immediately visible both to the engineer through the sort of persistent data gathering of the PRT system, and to the user through their selection of how exactly it is they're going to get through the network of the city. And contrary to Fabian's claims that this is essentially a cybernetic project, the underpinnings of the PRT model, both in Elias's case and in the case of the larger field, this is actually drawing from a different wellspring of system sciences, right? This is drawing from engineers' network flow theory, by which transit engineers model the city and the flow of people through it as a system of liquids, of fluids. And what PRT is, in essence, is the direct instantiation of that, not in terms of a roadway that you might drive on, something that you sort of see in aerial view, but in a system that will make these flows immediately visible both to the engineer through the sort of persistent data gathering of the PRT system, and to the user through their selection of how exactly it is they're going to get through the network of the city. Obviously, there's more to talk about this, but since I want us to be able to have some time for questions and talking about this with each other, I'll just, wrap it up here.